Hi everyone. This is just a quick video on how to find the area, or at least one strategy to find the area of a regular polygon. Um, on the page here you have a regular octagon. It has a radius of 12, and the radius is a line, or a segment rather, from the center, which I'll call right here, we'll call this center O, to the vertex, and that's 12. It has a side length of 9.18. We don't know the units, we'll just say they're units. Okay, now the first thing I would do when I'm trying to find the area of a figure like this, since I don't know a formula for the area of a regular octagon, is I would come up with a strategy. And notice what I've done is I've drawn some segments here. They're mostly dashed. And you can divide the octagon into 8 triangles. Triangle 1, triangle 2, triangle 3, and so forth. If you find the area of one of the triangles, and I'm going to go after the one that's shaded, and then multiply that by 8, you have the area of the octagon. So the area of the triangle, the shaded triangle, in general the area of a triangle is 1/2 base times the height being the altitude. I've drawn an altitude here. It's dashed in red. That's an altitude. It has a right angle right there. Now, one fact about a regular polygon, the radii are all the same. So this is 12, which means that the altitude divides the base in half, which means that in this triangle, half of this leg right here, the base is 9.18, so this little half of that is 4.59. And the reason I need that, because I need to find the altitude, I'll call it h, is I'm going to use the Pythagorean theorem. I know that h squared plus 4.59 squared equals the hypotenuse squared. That's 12 squared. So what I get from that is I get h squared plus, and I'll round to, say, start off through 4 decimal places, 21.0681 equals 12 squared, which is 144. I'm going to subtract 21.0681 from both sides, and h squared rather is going to equal 122.9319. Notice that the numbers are messy, and that's often the case. It happens in the real world. You've got numbers that aren't perfectly, they're not perfect integers. Now, what I need to do to find my h, to find my altitude, is take the square root of both sides. So h equals the square root of 122.9319. And when I do that, I'm going to round to 4 decimal places here. That is 11.0875. So that is the height of that shaded triangle using the Pythagorean theorem. And that would be units, right? So that would be units. Now, the area of that triangle, of the shaded triangle, is 1/2. The base is 9.18. The height, which I just found, is 11.0875. And when I do that, I get 50, and again rounding to 4 decimal places, 50.8916. Now, that is the area of this shaded triangle. That would be, by the way, units squared, since it's a measure of area. Now, in my regular octagon, I have a total of 8 of these triangles. So all I'm going to do is take the area of one triangle, so the total area is equal to the area of one triangle, 50.8916, times the number of triangles, and there are 8 of them. And when I do that, I get, let me go to my calculator really quick, that's going to be 50.8916 times 8. I get the total area of, and again, this is rounded to 4 decimal places, 407.1328. And again, that is units squared because it's a measure of area. So again, using the Pythagorean theorem, developing a strategy, all of these tools are going to be useful to find the area of more complex figures.